So, nuclear physics, a lot of people get confused about what the topic of nuclear physics is, but it's nothing more than the physics of the nucleus of an atom. So, this is an atom. Well, it's not an atom yet, I haven't put anything in it, but all atoms are made out of protons, neutrons, and electrons. And let's say I wanted to make a lithium atom. If I put one proton on there, all of a sudden it calls itself hydrogen. And if I put a second one on there, it calls itself helium. Now, the reason for that is that it's the protons that determine what atom it is. So if we take one away again, it starts off there, and when I give it another one, it says it's this one. Now, we can also so if I were to actually draw the symbol for helium, for example. Okay, hang on a second. Right. So the helium symbol for helium would be He, and then it may have a 4 at the top and a 2 at the bottom. Sometimes these numbers are the other way around, but basically we call this the atomic number. The smaller one was always the atomic number, whether it's at the top or the bottom. And then the larger one is always the mass number. There's only one case, which is hydrogen, when the mass number and the atomic number is the same, and in that case it doesn't matter anyway because they're both just one. So the atomic number, this tells us the number of protons. Okay, this is the number of protons, and basically we can think about the atomic number as saying that this is atom number 2. So atom number 2 has an atomic number of 2, and atom number 3 is lithium, which is this one here. Now lithium, I'm going to draw lithium up here. I just need to get the pen again. Lithium has a mass number of 7 and an atomic number of 3. Now you see here, it's got a mass number of 3, and if you watched carefully when I added protons and took them away, the mass number went up and down. This means that the protons have got a mass number of 1. Okay, so protons mass number equals 1. But I need a mass number of 7. So if we look over at the neutrons, they look roughly the same size as the protons. So we're going to put one of those on there. And yet the mass number goes up by 4, but it's still lithium. So that's good because we want to get the mass number up to 7. And the atomic number is already 3 because it's got 3 protons. So I'm going to keep adding neutrons until I get up to 7. And you'll see that I need to add 4 neutrons. So we can also say then that the neutrons, the mass number is also equal to 1. So what about the electrons? What was the mass number of electrons? Well, if I add an electron, it goes on the outside as well, if you notice, and the mass number did not change. Now, it doesn't have a 0 mass, but we can say that the mass is very, very, very small, so small that it's negligible. Okay, so we can do wiggly line 0, which means roughly, very close to 0. So what it does do is it changes the charge. If you notice, one of the things that we did when we took away and added the protons, it added a charge. So we can say that the charge of a proton is +1. What about the neutrons? What was the charge of the neutrons? Let's take away the neutron. Didn't make any difference. So the charge is 0 for a neutron. Okay. Charge is equal to 0. Whereas the electrons, that did have a charge, and in fact you can see it cancels out the proton's charge. So so the electrons are equal to so that's a neutral atom now. It's got 3 electrons, 3 protons. If we're going to look into chemistry, we'd look at these shells of electrons, but we're not too concerned about that. Nuclear physics is really more concerned about the inside of this atom. So what we're going to do next is we're going to look at different types of lithium atoms, different types of other atoms called isotopes. That's what I'm going to talk about next. Um,